Hi everyone, welcome to Build Your Own Developer Platform in 90 Minutes workshop. I'm Hofesh, heading developer relations and technical product marketing at Komodor. I'm also the co-founder of the Platformers community. And today with Engin, we're going to show you how to build an IDP using Backstage, Kubernetes, and ArgoCD.
Okay, then shortly to myself, my name is Engin Diri. I'm working as a customer experience architect at Pulumi and love everything related to cloud transformation enablement. I love shawarma, as you can see down in the thing somewhere here. And you see all my, yeah, shawarma is live. My credentials are also there, so if you want to follow me, there should be everything. I forgot to enter Blue Sky, but yeah, you will find me also on Blue Sky.
Hello, I already introduced myself, but here you can see my Blue Sky and then find Engin.
Sorry.
That's okay. Okay, so our agenda for today is, yes, I am a Kubernetes advocate, and this is Benji, my dog. And today we are going to do a quick overview of what developer platforms are, what use cases they fit, why use them. And then we're going to get to work, starting with deploying a cluster with DigitalOcean, then setting up ArgoCD as our CI/CD pipeline and source control, and then deploying Backstage, our developer platform UI, and then deploying our very first application to Backstage. And to finalize things, we're going to destroy everything and throw it away. So let's move on to the very first part. What is platform engineering? So platform engineering is a practice of building and operating a common platform as a product for technology teams. Or in simpler terms, it means that the landscape of software development has become too complex, too convoluted. There are so many libraries and languages and frameworks and tools and monitoring tools and security and testing, and it just becomes too overwhelming for development teams and other teams who also need to consume those resources or that data, like data engineering teams or BI teams or for whatever use case. So the practice of platform engineering means basically abstracting all that complexity and making it accessible, making the functionality accessible through a shared platform, through a shared UI. In this case, we are using Backstage as the linchpin, but there are many other available tools you can use. Next slide again. So here's an example of an implementation of what that might look like. And you have the platform team who are building and maintaining the platform itself. And the key here is that they are treating it as a product, not just a project that has a beginning and an end. They are treating it as a product and the developers as their customers, as the end users. And that is a shift in the mindset, in the sense that you are not you have to collect feedback, create feedback loops. You have to improve. You have to release new features, and you basically have to make it a living, breathing thing that evolves over time. And here's one evolution of such a platform. And as I said earlier, the complexity here are just a few tools that are a part of any modern organization. The way we want to move forward is to shorten the development cycles. We want to reduce cognitive load so we can let developers move faster. The current pace at which organizations are able to release new software, able to innovate and compete, is unacceptable at this stage. So something like a developer platform is useful to address all of those challenges and have a centralized, consolidated place that different teams, like in this case, we have different teams consuming the services from the platform that has different building blocks within it. And as we'll see, those building blocks are interchangeable, and there's no one size fits all. Every organization is different, and there are usually a few best of breed tools for each category that you can use or replace interchangeably based on what makes sense to you. And moving on. So quickly, a blueprint of what we are building today. So we are using Kubernetes as our base, as our platform, and GitHub will be our repo. GitHub code spaces, to be precise, will be our repo, and we will deploy the cluster using Pulumi, and the provider this time will not be Civo, it will be DigitalOcean. So it will be a DigitalOcean cluster on which we will deploy ArgoCD as our CD pipeline and GitOps engine. And finally, we will deploy Backstage. And Backstage, like I said, will be the linchpin of everything. This will be the where different teams can go to window shop, template services, and other resources they may need. And then we'll run our first application on this beautiful thing that we will construct. So moving on, prerequisites. Forking the GitHub repo. So I already did that. I already have an account with GitHub Codespaces, and I just forked this repo. So I should be ready to go, right, Engin?
The token is also not valid because we're using DigitalOcean. Udi has already the DigitalOcean token. And if you're going to recreate this on your own, just use your own DigitalOcean token, and then you're good to go. So yeah, share your.
Okay, I'm setting up Codespace.
You want to share your screen or your window?
Mm-hmm.
And the moment it's up, we go quickly back to the slide, and then we show you chapter 1, and then Udi is going to do this. So we use here the dev container. In the dev container, everything is already installed, all the tools you need in this case. So the Pulumi CLI, kubectl, Helm, and everything is installed. So you don't need to think about which version to use or to have it installed on your system. That's very practical. And then using the remote code space to just execute the dev container. You could also use Gitpod. You could also use your VS Code with the dev container extension locally. It's really up to you. It gives you the flexibility. So highly recommend to work with this. And yeah, here we're done.
Perfect.
So
okay, so we need the README file.
My slide. Yeah, can you put my slides on stage again?
Yes, and here you go.
Okay, so what Udi is now going to do, and you folks at home, execute the cluster.sh shell script, and in the background, what it's going to do is we're going to execute the Pulumi file. The Pulumi infrastructure as code file describes the DigitalOcean cluster, and it's going to install the DigitalOcean cluster. It will also export the kubeconfig because we need later on the kubeconfig for installing ArgoCD and all the stuff. And every property we need will be added to a .env file, which will then cascade it through the different steps. So we made an approach which is easy, accessible, and followable for people. If you want, you could also create everything in one infrastructure as code file. That's up to you. Okay. Short, really short introduction to Pulumi. So we use Pulumi. You could also use Terraform or a different infrastructure as cloud provider of your choice. The benefits here of Pulumi is, what is Pulumi? I make it really short. It's modern infrastructure as code. What we mean with modern infrastructure as code is that one of the perks is it uses familiar programming languages and tools. So you can use your Python knowledge, you can use your Go knowledge or TypeScript knowledge to define your infrastructure. I recently read somewhere that the most popular language currently, according to GitHub, is Python. So Python overtook JavaScript, which is very interesting and nice. So if you already know Python or you dive into the whole AI world, you can create now the infrastructure you need for your AI workload also using Python. It works with any major cloud provider, so that's very important. And of course, in the world of new licensing and all the things what's happened in the past with license changes, it's also worth to mention Pulumi is open source, and you're good to go to use it. If you want to use a little bit of the commodity of having a handling of your state files, there's a generous free tier on the Pulumi cloud offering, so you don't need to handle all the state files on your own, and that's completely fine to use. So just a short overview. So we have this free pillar. We have build, deploy, and manage. So build, as I mentioned, you can use your programming language in your IDE environment, which is very convenient. So there's no need to install any plugins or something like this. Continue, import the Pulumi package, in our case, for example, the DigitalOcean package, in your code, and then work with it and use the dot annotation to get all the properties you need that have the type safetiness. So that's the build part. Deploy, as I mentioned, having a rich ecosystem of all the major cloud providers and SaaS systems is also helpful to create end-to-end stories from GitHub to deploying on an EKS cluster, for example. Udi mentioned platform engineering, creating stories for our customers. So here you can create an end-to-end story for whatever service your internal customers is needing and manage. Pulumi is not inversive. Pulumi doesn't tell you how to use it. You can use your existing Jenkins, existing CI systems you already have in place. Pulumi is offering also a Kubernetes operator. So if you're all in this way to say, hey, I'm already in Kubernetes and I have already a GitOps engine in place like ArgoCD, why not use the operator? Okay, how does it look like? Here we have a YAML example of a Kubernetes cluster. And then if you're happy and say like, hey, we decided on a programming language, you can use Pulumi convert to convert this YAML into any target programming language and then continue from this. If you say like, no, I'm fine, I want to continue with YAML approach, but I would like to have some more flexibility, you could slap, for example, Q on top of it, for example, and just continue with this approach in YAML or go to a programming language. So how does it look like then? The same definition in Go. This is the Go code, no control structures into it. Yes, you could, of course, now loop and create 10 clusters and all the stuff with a simple for or while loop with a condition. Same goes for the TypeScript approach. And that's it. So let's head over to Udi before we continue with step 1. So I remove myself from the stage.
Okay, so now I have entered the Pulumi token and the DigitalOcean token. And basically, we are creating a cluster from scratch.
Yeah, that's fine. So if you could, while it's spinning up, if you go into the folder infra, and no, not sorry, infra, it's where is it? IAC, sorry, in the folder IAC, and then in the DO cluster and open the pulumi.yaml file that we can see. So, and then you can see the Pulumi YAML file here in line 16. It starts the definition of the cluster. So we're not adding any additional node pools. It's going to be just one node pool, but a beefy machine which handle all the workload. As you can see, we're defining the region, defining the properties. You can use them as variables, so you could feed them in when the people ordering it. So that's very interesting. Then we create on line 27, we create a Kubernetes provider. And in line 33, we're going to install the ingress controller. This is necessary because the Kubernetes cluster has no way to route traffic in. And we're going to use this for ArgoCD and Backstage, that we can use the UI and call the UI. So that's the reason we're going to install the Nginx ingress controller after the Kubernetes cluster is created. And depending on the cloud provider, this takes a couple of minutes. And as I mentioned before, to keep the workshop repeatable for everyone and not push anything into the infrastructure as code part, we removed ArgoCD and the Backstage installation in separate steps. But as you see with line 33 to 45, you could also define every installation, everything inside your infrastructure as code tool. You could split it in 2 different programs and say, okay, I'm going to take, because when you scroll up, Udi, in the top, what we defined here as an output in line 6 and 7. So we see in line 7, we export the kubeconfig file as an output. So you could say, okay, I create one project which creates the base infrastructure. This could be something like the infrastructure team providing it, and then treating everything which gets installed as applications. So you could, for example, give the development team, as a result of your bootstrapping via Backstage, for example, or via another IDP system you created, they have access to the kubeconfig, and then use a second program to just deploy applications on the Kubernetes cluster. It could be the CLI, it could be the Helm because you have the kubeconfig, or it could be another infrastructure as code tool. So we see now from the logs, we are already in the stage to create now our deployment of Nginx ingress. This will also take a couple of seconds, depending on how quick the stuff is. And as soon as it's finished, you are good to go. Everything we do here is also described in our README file. So you have the README file, which guides you again through all the steps to check out clone, starting code spaces. And then also in the demo.md file, it's all the steps you need to run the demo. And again, using DigitalOcean should give you the way to recreate this at home, because I think that's accessible for most of your people. If you don't like or you want to try it differently, feel free to change the code and use, for example, EKS. All you need to do to take care for this part is to export the kubeconfig file. So that's the most important thing you need to keep in mind. So, and now I run out of words because it's still spinning up the release, but it should hopefully not take that much time. Let me see how long it took when I did my trials. So this creation took at my place 175 seconds. So you should be now just a couple of seconds away to finish the stuff. But while this is doing, I prepare the slides for the next part. And because this is a video, you can just fast forward us with 2.0 or just jump to the next mark. We could enter also the marks, Udi, for the chapters. So probably you may not see this waiting sequence of us. So.
Yeah, we can just do a DigitalOcean. We'll be right back.
DigitalOcean, right back placeholder. But it should be now good. I mean, in my example, yeah, 160.
Oh,
okay, that's good. Then
I finished faster.
The slides. Yeah, perfect. Okay, so cluster is set up. Everything is ready to continue to install ArgoCD. And so to install ArgoCD, again, there's a convenient shell script created for this. It's called the setup.sh. The only thing Udi needs now to provide and prepare now in the background is the GitHub org. He cloned this, so you just need the name part, nothing else, just copy paste the name part and the GitHub token. And because he's using a code space, he doesn't even need the GitHub token. It will be auto-completed. In case you're not using GitHub code spaces, prepare your GitHub token. So what happens in the background is we substitute some different values we collected here in the YAML file for ArgoCD, especially the IP address of ArgoCD. Then we're going to install ArgoCD using the Helm command. And what we also do is we push some manifests to enable our GitOps action. So everything should be ready and armed. Again, some little background information to give you a little more insight. So big question, GitOps. When we were in during the workshop, we asked how many people are using GitOps. So it was, let me think, 5 or 6 people in the whole room. So it's very interesting.
Yeah, like a handful. And it's always half of the people who say they use GitOps aren't really doing GitOps.
Yeah.
So it was like maybe 2 or 3 people. Mm-hmm.
Which is completely fine. I mean, this is the workflow you probably have if you're not using GitOps. So this is not GitOps the flow. This is a classical push approach. So we do all our magic in our Git repository, and I hope everybody at least uses some kind of version controlling. Here in this example, we have Git in place. And then anytime when some changes happen in your Git repository, some CI system kicks off. It could be Jenkins, could be GitHub Actions, GitLab, and whatever, starts and build images or build your artifacts. In this case, we create a container image with the app code and the app infra definition and so on and so on. It gets pushed into our image repository. Again, it could be JFrog, it could be GitHub, it could GitHub container registry, and so on and so on. The moment this is also done, the CD step kicks off, collects all the information, maybe substitutes also values in your app infra definitions and so on, and then makes a kubectl apply or a Helm install, depending on all the different clusters we have. So it could be it iterates through, so similar what we do now, getting the kube config from a cluster, be it saved somewhere, and just keep Helm install, Helm install, Helm install. So you see we push to a cluster, and you can already see some of the situations which maybe sounds uncool, undesirable, and especially from a security perspective, you need to have the access to your clusters. So this is something which people maybe don't like and want to avoid this. And now we come into the better world. So the CI part stays still the same. So we really reduce the Jenkins or the GitHub just to the CI part. So create my stuff, test my stuff, everything which you are supposed to do. But we now commit our infrastructure definitions and app infra definitions, maybe in a separate Git, maybe in a subfolder on this. So from this part, it could be still similar. But now we have as a centerpiece our GitOps engine, could be Flux, could be Argo, whatever you're using. And this GitOps engine is now set it up to scan the Git repository for any changes and then install them either in cluster, in the cluster the GitOps engine is installed, or there's also an approach of a hub and spoke. For example, in ArgoCD, in Flux, you could create now on every Kubernetes cluster, you could create your own Flux, and the own Flux also listens to specific Git repositories, branches, folders, you name it. And as you see, now we have a connection from the CI to the Git, because the moment you created a new container, you have a new hash of this container. You can add this also in a Helm value or in your deployment YAML or the daemon set YAML, it depends. So very interesting approach. And now you can handle your fleet management without having all the information stored somewhere else, because every unit of this fleet is taking care to update themselves because we defined it. What is ArgoCD? So mentioned before, now we zoom out this GitOps engine. We see, yes, ArgoCD is then also an installment of on Kubernetes. What ArgoCD is doing, it's going to extend the Kubernetes API with new definitions, so-called CRDs. So in this case, it extended it with the CRD application and application set. There are some little differences. Feel free to look them up. We're going to use application. And then ArgoCD is also deploying it to the cluster. Here in our case, we just have one cluster. So it's going to deploy this into this one cluster. Okay, so Udi, it's your turn.
Okay. So now we will talk about Backstage.
Okay, Udi, just execute now the setup sh file, please.
Okay, executing. Yes, I do have these tools installed. My GitHub org is Udi Hofesh.
That's fine, your GitHub, because it takes it from the code space. If you don't use GitHub code spaces, please enter your GitHub token you have to create. And this is now installing ArgoCD for us. And then you will be presented with a nice, cool UI. So if you click on it, you maybe have to type HTTPS, depending now when you click on it, if doesn't anything appear, try it with HTTPS.
Okay, perfect.
Okay, just share. See ArgoCD.
Here it's ArgoCD, and we can already see we have some applications. We have the infrastructure in here.
Perfect. Then you need to put my slides back on stage, and then I can go to step number 2. Okay, so now we set up the cluster using Pulumi. That worked fine. We exported everything necessary, the kubeconf and everything we need to install ArgoCD. Udi presented the installation of ArgoCD. That also worked like a charm. And now we can go to the next step to say, okay, let's deploy. Oops, come on. Let's deploy Backstage. Okay. In this case, we're not going to execute any specific shell script because this is part of the workshop. Just go step by step to understand what we're going to do and what commands we are executing. Again, you can later automate this completely either as part of our infrastructure as code or create a different type of shell script. So open the demo MD file, and then we go through the points. Udi will do this. What happens in the background again? We're going to install the Postgres SQL operator. So because Backstage is going to need a database, so we install the Postgres operator. Then we install a Postgres-specific CR telling the operator, hey, I need a Backstage database. So it will then spin up the Backstage database. We're going to install the sealed secrets operator because we want to submit also secrets into our Git repository, because at the end of the day, we're using GitOps. So everything should be in Git defined, and because we cannot just plain text our secrets and not base 64 hashing it, because that doesn't really is a protection. We're going also to try to encrypt them, and then we can commit them using sealed secrets. In a real production environment, you probably use a different secret manager. So sealed secrets is good for demoing and all this stuff. But if you go on a large scale, you will quickly see that this doesn't really scale well. So use something else. And finally, we're going to install Backstage, and then we will meet again for the next step. But this is it for now. So passing it to Udi and his IDE screen.
Okay. So I executed the command.
Yeah. So
to install Postgres. Now.
Yeah, he already did. We see this, the CNPG is already installed, so you can continue with the CLI steps. That's nice. Cool, okay. Cool.
Next step, as we have observed.
You need maybe to share the screen.
Oh, yeah, sorry, I'm sharing the wrong screen. And here we are back at demo MD.
So yes, so you installed the Postgres part. So now you have to go to line 37 probably. If you go to line 37. So there's something now you need to do in line 37. Or did you already committed this?
This is...
Yeah, okay, perfect. So we are, it's working. And now you can copy paste, the next lines. So the Postgres cluster is up and running. We see it's in a healthy state. And now we can get some out of the information. So in this case, getting here the password. And let's see, with line 56, copy paste this one, 56 and 57. Okay, this is, as I said, up and running. So now what we do in line 63 is we connect to the to the container with the database running it and do some PSQL magic. Don't ask me what's, I'm not a database expert. Okay, so that's fine. That's working everything fine. So now we can head over to our sealed secrets approach. Similar, copying the commands. What this is doing is just installing the sealed secrets operator. So we see now when you scroll a little bit up in the terminal, that's the application, the ArgoCD application of type of application. Name is sealed secret, and defining the repository where the sealed secrets Helm chart is. And if you scroll a little bit down in the terminal, then we see it's going to delete and then pushing it to GitOps. So GitOps is pushed. So when we head back now to ArgoCD, we should see now, depending how you set up. So normally we have a reconciliation loop of a couple of minutes, and then it checks all the time the Git repository. You could install a webhook to automate this part. In our case, we just go to the UI and click the deploy button because we want to see it quicker. But you don't need this. So we go to the production infra when you go back to applications and just click the refresh button. And then you see, yep, sealed secret, the application appeared. If you go back on the start screen of applications of ArgoCD, you see now there's a new tile coming up and sealed secret is also deployed. Perfectly, everything's green. So we can continue with the next step.
Moving on. Okay, so we saw sealed secrets rolled out in ArgoCD, and now we're going to create the secret with kubec. So we see in line 112, we get out some informations. We create then our sealed secret YAML in line 117, and you will see this when Udi finished the part. So if you open now the folder Backstage on the left side, Backstage resources, you see perfect. Yep. It's encrypted how it has to be. If you go back to your demo MD file and continue with 120 to 137. So just, yeah, perfect. Okay, so now you should have the Backstage URL. Yeah. Okay.
Okay.
I do have Backstage.
Just share it. Okay, perfectly fine.
Backstage,
as it has to be. So now we can continue with the second part. So you had wait just a second. Where is it? So now you can share my screen again.
Yeah. Back to
Backstage.
Backstage is an open source platform developed at Spotify. And what it does is it enables any developer to create a new software, manage, monitor, optimize, troubleshoot the software that they own, and explore the landscape of software in the organization, be it documentation or libraries, APIs. And the goal of all of this is to make developers not just happy, but also autonomous, provide them with self-serve, and that in turn translates to faster development cycles, less employee churn, better user experience, ownership, and most importantly, peace of mind for the operators of the ops teams. So next slide is an example of an implementation of Backstage. So what you see on the right is an example of a company catalog that has all the important components bubbled up. And as we said in the beginning, everything is customizable and interchangeable. So maybe for you, Kubescape or ArgoCD are not the relevant tools. So imagine that that's BlockCD or Diri or whatever. You can also see a Komodor tile here, and it shows a scorecard for different things like cost efficiency, availability. And with Komodor's public API, you can customize it to bubble up any type of data you want. And same goes for any other type of plugin. Backstage is built in a plugins-based architecture. So you have open source plugins, you have vendor-based paid plugins, but you have the freedom to construct it in your own way. And so some of the things that we see people use Backstage for is once as a portal, as a gateway for developers into everything software or infrastructure related. And it can be used to visualize dependencies like we see here in the relations tile. And it can and should be the single source of truth for everything in the organization. And as we said, the goal here is to make things easier, to make developers think less about those things so they can focus on moving fast and writing code. And moving on.
Yeah, that's it. That was the short instruction. Okay, so we deployed this. Udi showed this. Backstage is up and running. And so now let's deploy an application. So we're going a little bit different route this time. We don't create it now. How do you say this? A service catalog where you can bootstrap via Backstage. What we do now is we're importing an existing project into Backstage, and there are different ways to do this. So he will continue with the demo MD file where we deploy a user API app, and in the background we annotate everything inside a so-called Backstage component YAML file, which looks very similar to a Kubernetes YAML file, but it's not. And inside there, you can define all the properties and everything necessary for the plugin. So you will see later on when Udi commits everything, the slug in the metadata field where the plugin reacts on it, and then it connects everything. So you see the tile for ArgoCD, and you see also the Kubernetes tile. Everything work together because it can look up the informations inside the component. So, but we will see this now. So head over to your GitHub code space, and then we can continue.
Yeah, that's fun. Okay.
Okay, that's perfect. Head over. And what we did now is deploy the user application, again, creating an ArgoCD application. So if we go to ArgoCD in your UI, you should see a new tile when you refresh the production apps tile. Production apps. Yeah.
Oh, sure. Sorry.
That's fine. That's fine. So close this one. Yep. And this one again. And you see user API is now deployed and it's working also. That's cool. And finally, heading back to our code space. So applications deployed, think about it's maybe already running. You want to retro import them into Backstage, or you just don't want to provide a user interface for bootstrapping. Something could be also necessary. So what we're now going to do is this so-called user app component. We will have a look on it the moment Udi, there's a C missing on the cat.
Okay.
So, okay. So if you open now the user API folder on the left side, so and have a look into the user app component. So that's something Backstage will going to look into it. So we see now in the annotation in line 7 and 8, we see now the annotations necessary for the plugins. So the first one tells the Kubernetes plugin where to display the information only for the user's API. So you see the pod deployment and so on attached to it. Very necessary. No need to switch around. The line 8 is the ArgoCD. So ArgoCD tile Udi showed in the example one gives the information about the state of the application. Is it successfully deployed? Also happens here with the ArgoCD app name. Everything else are meta informations you may auto-populate or you may statically have in, for example, line 27, the owner, should not be you, should maybe a user ID from your LDAP, which is connected, and so on and so on. If that's this part, if you go now to the catalog folder on the left side, this is what we tell ArgoCD to Backstage to look in. So if you open the catalog, all YAML file, so you see we created now again a Backstage specific manifest file. This is not related to Kubernetes, so the Kubernetes API doesn't analyze this one. It's just that Backstage is pointing here, and we tell Backstage, these are all the properties under targets to build up your catalog. So you can think about this now. Existing projects, what do they need? They just need to find to add a component YAML file into the Git repository and then tell Backstage where to look. It could be a static file like here, or you can create instead Backstage also as some kind of dynamic discovery where you point your GitHub organization. It will go through all your Git repositories inside your organization and only look for the component file. So you can retrospectively inventorize your whole organization, or everything you created automatically take care that the component YAML file is populated. A very cool approach to get the information out. So with this said, we have a look into Backstage, into ArgoCD, roll out the missing pieces. So if you
Going back to demo MD.
This is all done. You also Git pushed everything. So when you
I'll
go
just
to
go
Backstage,
Backstage.
Yeah.
And here we are.
So just refresh your Backstage, and you see it's already there. So perfectly, all the tiles are there. Of course, you can build now the relationship a little bit better. Say, hey, the user API is part of an e-commerce platform, so you see in the graph a little bit more information, and so on and so on. Most importantly for our demo was to show the interaction now with ArgoCD. So when you scroll down, you see the ArgoCD tile in the overview. Yeah, so if you click on it, then you see some additional information. Where does it come? The image names, and so on and so on. This is all made by the providers of the ArgoCD plugin. Cool. And if you scroll up to one of the tabs, there should be now a Kubernetes tab. And in the Kubernetes tab, you see, yes, it's deployed currently on our local cluster. If you also have multiple clusters, you can all configure them in Backstage and see they are running there. And you see all the information. If you continue to scroll down, if you click on the next one, yeah, on the user API deployment, on Kubernetes, sorry, and then open this one, and then click on the deployment, yes, and click again on this one, on the name of the, you can see now informations around your pod, and you can see the logs also. So when you click on logs, you get also the information. So you, as Udi said, now we get all the informations. A development team, a project team needs all inside their components. So we have an inventorization going on. People can look up what components are existing, who are the owners, and the product team can then do some additional day 1, day 2 operations, or just use it to jump off to specific dashboards and all the stuff, or aggregate everything inside. Okay, that's it from this. So let me go back to my slides again. Where are you? So
now for the fun part.
Yeah, because we need to housekeep. So you could.
Here you are.
So that's again what we did. Create ArgoCD app, move the folders to the app. So then the production apps ArgoCD can react on this, and everything is committed. That worked also like a charm. So now we come to housekeeping, so that we're coming to the end of our workshop. So we also need to clean everything because we don't want to generate any costs or leave any unnecessary cloud resources running. So what we're going to do here is simply call the destroy sh file. What does it do? It removes the apps and the infra from the Git repository. So ArgoCD is like, okay, everything gets deleted, and the moment the thing is deleted inside ArgoCD, we then also deconstruct our DigitalOcean cluster. And this is something you can do.
And it is done.
Okay, just.
As you were speaking, I executed the Pulumi destroy. And now.
Yeah, you can share yours. And just from 34. Yeah, so just copy this. Everything from 34 until
50.
Yeah. Okay, perfect. So this is now what we said. Deleted everything. So the apps folder is empty again, and the infra folder, as you see, is also empty. And that's what we would like to see. I think it doesn't continue there because Pulumi destroy already destroyed, and then just errors out because there's nothing to destroy. So it's exit the bash script. But yeah, that's it. That was the workshop.
So just a quick recap before we go. So we using DigitalOcean and Pulumi, we deployed a Kubernetes cluster, and using our GitHub repo as the source control, and then we deployed ArgoCD as our GitOps engine, and then we deployed Backstage, right, secret manager, and then deployed our first application to Backstage, and finally demolished everything using Pulumi to avoid spending resources on this cluster any longer. It has served its purpose, and now it is gone. Any last words? Any finishing remarks?
No, that's fine. So you could see, of course, this is far from our production setup, but it gives you a good idea how to stick all this little building blocks together to create a larger story. So what you have now is Kubernetes as your runtime and Backstage as your interface for your platform, and some little parts like sealed secrets to provide a secret as a service. And this is a good starting point. So let us know. We are reachable over LinkedIn, Twitter. I think there's plenty of ways. Yeah, Blue Sky, Slack. You can find us everywhere. Let us know what you think. And yeah, I hope you enjoyed it, and see you next time.
Absolutely. Thank you, Engin.